Assalamualaikum and very good morning to everyone. I'm Dr. Narazwan Makno, will guide you in this course. Welcome to EKC 316 separation process. In this semester, 2020-2021, I will guide you in this first half of the semester. So, without further ado, this is the separation process introduction video. Separation process. Why does chemical engineering require the study of separation techniques? Alright, this is your first task. I think you have your idea or your opinion regarding this question. So, just scan the QR code and give your opinion in this Padlet. Your participation and your opinion will be remarked as your attendance for this course. You can submit your opinion after this session until our next meeting. There are many reasons or requirements for pure substance, from the small scale until the large scale. For example, in small scale, you have your analytical separation, where you will conduct your chromatography and you need to separate your samples. As for large scale, such as in industrial separation, we have columns to distillate and to get the substance that we require. So, from small scale to large scale, there are needs and requirements for a pure substance. There are four fundamentals of separation. The first one is mass and energy balance. The second one is thermodynamics, transport phenomena, and also chemical reaction kinetics. In mass and energy balance, you need to know or have a fundamental understanding of conservation of energy and matter. Then, you also need to know the phase of equilibrium and the solution to the thermodynamics. Chemical reaction kinetics fundamentals are also required, such as the rate of conversion of one species to another, meaning that the fundamentals of these knowledge are very important. But why we need all this fundamental separation? Alright, we will look. This is the modes of operation. There are batchwise, continuous, and also semi-continuous. All these modes of operation, the separation process will take place. So the knowledge in the previous fundamental, will help you to go through all of these reactions. It's either batch, continuous, or semi-continuous. The fundamental is still the same. So, beside the modes of operation, you also need the fundamentals of understanding in block flow diagram and also process flow diagram. Alright, so do you still remember your block flow diagram and also process flow diagram? Okay, usually we call block flow diagram as a block diagram and process flow diagram as a PFD. So block flow diagram usually represented by rectangles, to represent key operations, and also lines to show the flows and stream. So in block flow diagram, you have your rectangles and lines. However, for your PFD, you have your realistic symbols of process equipment, including the auxiliary operations. So both of these diagram you need to know so that you can represent your separation process correctly. This is the block flow diagram and PFD. So as you can see in your block diagram, okay, for distillation there is only a rectangles and lines, okay, to represent your distillation column. However, for your PFD, you have your symbols and also the auxiliary unit operation. So for distillation, you only represent your major unit operation. However, for PFD, there is a complete unit operation with its auxiliary units. Okay, so please remember which one is block flow diagram and which one is your process flow diagram. Alright, so what is this? Okay, this is the block flow diagram. Okay, because you have your rectangle and lines. Okay, so it only represents all the major unit operation. So as you can see, this is the example of recovery of hydrocarbons from wet natural gas. Alright, these types of separation, okay, this is the operation process, the separation process, okay, for this process. This type of separation generally exploit the difference in volatility to cause a separation, okay. It uses the volatility, meaning that the ones that will vapor up or volatile, okay, will be separated. So you can see there are many columns just, okay, to separate from the raw material, which is ethylene. So this is the block flow diagram. So what is the mechanism of separations? Okay, there are many mechanisms for separation. However, the major mechanism of separation is based on differential transport. Okay, since separation is a non-spontaneous process, okay, separation is not a spontaneous process in nature, okay, it don't happen automatically or spontaneously, okay, so you need a force. This is the force, the differential transport, okay, differential transport causes different chemical components to move to different spatial location to be collected as more pure mixture. So you need to apply a force so that the separation will occur. Usually, the non-spontaneous separation process happen in homogeneous single phase. If not, okay, if your mixture are not homogeneous or are not in a single phase, you have to separate the phase first, okay. It's either using gravity, centrifugation, and also filtration. But how you can separate through gravity or centrifuge or filtrate? Alright, we will look further into this after this. These are separation process techniques that will be covered during this semester. Okay, there are 4 types of separation process technique. Okay, as we classify as a phase creation or phase addition, physical barrier separation, solid fluid separation, and also separation by gradient or what we call as a mechanical force. Okay, this is the one that we have tell you. Separation by gradient or by mechanical forces. So, by using gravity, by using gravity, we can have a sedimentation. Clarifiers. Do you remember your wastewater treatment plant? Where we have our sedimentation and also clarifiers. So, that are the separation process. Okay, we will look back. What is the phase creation and also phase addition? In this separation technique, we either use heat transfer base or mass transfer base. Okay, for heat transfer base, we use our separating agent based on energy. Okay, the use of energy separation agent, okay, by heat or depressurize, okay, heat energy or pressurized energy, we can make the separation process occur. Okay, for example, the evaporation and also drying. For mass transfer, we will use our mass separation agent, MSA. Okay, for example, we can add solvent or absorber so that the crystallization or solvent extraction process could occur. Then we have our physical barrier separation. Okay, through physical barrier separation, we will use membranes. Okay, we have filters, membranes, microfiltration, ultrafiltration, nanofiltration, and so on. So these are based on physical. So there are physical barrier separation. The third one is the solid fluid separation. Since there are two phases, we will use a solid fluid separation. Usually solid fluid separation happen in column. Okay, it is a column base and use particles. So inside the column, you will have the adsorption process, reaction, ion exchange, and also chromatography process. Alright, so most of distillation column will apply this technique. It's either using ion exchange or adsorption. So through this semester, we will cover all these four techniques. Okay, either using energy separation agent, mass separation agent, membrane, column base or solid fluid separation, and also the separation by gradient. This is the example of the block flow diagram represented in separation process. As you can see, this is for phase creation. You have your mass separating agent. You have the barrier separation using solid agent separation, and also by the force field or the gradient technique separation. So these different types of separation techniques will be represented differently in your block flow diagram. This is your PFD. As you can see, there are distillation column and so on. Okay, for example, this is unit V3O2. So you can see this is unit V3O2. It is liquid vapor separator. This is unit T301. Okay, where is it? Okay, T301. This is the benzene tower. Alright, to separate the benzene. And 302 is a EB tower, ethyl benzene tower. Okay, this is the distillation column. Okay, so you can see the difference between the representation in your block flow diagram and your PFD. So through this course, I hope that you can complete and you can understand what is separation technique, how to represent it in your PFD, so that you can apply it during your 4th year and in your career. Okay, that's it. Okay, that's all for now. I hope you still remember that you have a task. Okay, just go through and scan the QR code and give your opinion why we still need to use a separation process in chemical engineering. Okay, see you in other video. Thank you and goodbye.